Again, here we're finding the difference in two rational expressions, simplest form, and state any restrictions on the variable. So, we're going to find our least common denominator by finding our least common multiple of our denominators. In order to do that, we need to factor. So, here, we factor our trinomial. X times x is x squared. 2 multiply to 2 but add to 3 are 2 and 1. Same signs, both negative. Common denominator here, my first rational expression there has just x minus 2. My second, my denominator is x minus 2 and x minus 1. So I drop down the largest exponent of each factor. Here I have just x minus 2 and x minus 1. This is my least common denominator. While I'm dealing with my denominators here, I'm also going to find my restrictions on the variable. So I have an x minus 2 that can't be 0, and I have an x minus 1 that can't be 0, which means x cannot be add 2, add 1. X cannot be 2, x cannot be 1. Those values would give us division by 0. Can't have that. So now that we have our common denominator here, I'm going to match my denominators. So in my first rational expression here, I have an x minus 2, but I don't have an x minus 1. So I need to multiply by x minus 1. Whatever I do to the denominator, I have to do to the top. My second one, I have an x minus 2. I have an x minus 1. So I don't have to change my second expression at all. My first one, I'm going to simplify my numerator there, and I do that by FOILing. X squared, firsts, outsides are 3x, insides minus 1x, last, over my least common denominator. And I didn't change my second one at all, so I can leave that exactly how it was. And it doesn't matter here that I wrote my denominator in different orders. 2 times 3 is the same as 3 times 2. It's called our commutative property. We can move the order of those, and that's okay. Now, I'm going to go ahead and combine these to be a 2x. 3 minus 1 is 2x. Now that I have a common denominator, I can put my numerators together. Sorry, we switched that to a 2x. X squared plus 2x minus 3. And when I go to subtract here, I need to subtract both pieces. So minus 6x minus negative 7 gives me a plus over my common denominator. I'm going to go ahead and combine like terms in my numerator here. I have an x squared. I have 2x minus 6x, so minus 4x. Negative 3 plus 7 plus 4 over my common denominator. I'm going to factor my numerator. Multiply to 4, add to 4 are both 2's. Same signs, both negative here. And every single time I take something divided by itself, I get 1. And I can cancel those out when I'm multiplying. Not when I'm adding, but when I'm multiplying. All I'm going to get here is x minus 2 over x minus 1. Again, we can only cancel factors, okay, not terms. Things that are multiplied together, not added. X minus 2 over x minus 1 as long as x is not 2 or 1. One more subtraction problem here. First step, common denominator, and we get that by factoring. Multiply to 5, add to 6 are 5 and 1, both plus. Common denominator, And I know some of you are probably looking at this like, why does she keep writing those out? We get it. We get it. Pretty soon we're going to get into things that are a little bit more complex. And just to make sure that we have this process down, to find our least common denominator from our least common multiple, I'm going to keep going through this. So we have 1 is our highest exponent there, and x plus 1. This is my common denominator. Once I find that, I'm also going to find my restrictions on my domain, because no part of my denominator can equal 0, which means x plus 5 can't be 0, and x plus 1 cannot be 0. No factor in my denominator can be 0 because I cannot divide by 0. Subtract 5 and subtract 1. Those are the restrictions on my domain. Now, when I look at my denominators here, this one's fairly easy. I already have the x plus 1. I already have the x plus 5. My second one, here on the left, I have the x plus 5, but I don't have the x plus 1, so I need to multiply by the x plus 1. And again, we're multiplying that whole thing. Whatever we do to the bottom, we have to do to the top. And we're taking that whole x minus 1 factor times x plus 1. Now my denominators are the same. I have x plus 5 times x plus 1 for both. My numerator, I'm going to FOIL here. X squared plus x minus 1, which plus x minus x is 0. I have x squared minus 1. I'm also going to bring over my x plus 3 from right here. Now we have to remember to subtract both of those pieces. So when I put this all together as one fraction over my common denominator, because again, when we add and subtract fractions, once I have my common denominator, I combine my numerators by either adding or subtracting based on the sign in the middle. I have x squared minus 1 minus x minus 3. We subtract both pieces here. Distribute the negative, minus x minus 3. Go ahead and combine my like terms and put it in standard form, which means biggest exponent on down. X squared minus x minus 4 over x plus 5, x plus 1. Is there anything that multiplies to 4 and subtracts to 1? Sure isn't. So we can't simplify that any further. This is going to be our final answer, as long as x is not equal to negative 5 or negative 1. If we wanted to here, guys, again, we could have multiplied our denominator, x squared plus 6x plus 5. So either one of those would have worked. Doesn't matter to me if you have it in standard form or factored form. No preference. Okay, again, our numerator does not simplify, so there's nothing else we can do there. A complex fraction is a rational expression that has at least one fraction in its numerator or denominator, or both. There's some examples on the bottom of page 536. Basically, complex fractions are fractions that have fractions in them. Okay, example 4 here says, what's the simpler form of the complex fraction? There's a couple different ways you can do these, guys, and if there's a way that works for you that gets you to the same answer, go for it. The way that I'm going to show you is to simplify your numerator, simplify your denominator, and then divide. So I'm going to treat these as two separate problems to start with. First thing I'm going to do is I'm going to add my numerator. My common denominator here is x, y. I'm missing a y, so I'm going to multiply by y. Here I'm missing the x, so I'm going to multiply by the x. Gives me y over xy plus x squared over xy. Now that I have a common denominator, I can combine those into one expression by adding my numerators. And I've got my numerator as simple as I can get it. I'm going to do the same thing with my denominator. Remember, if it's just a whole number, it's written over 1. So my common denominator here is y. I have a y, I need a y. So I multiply top and bottom by y. Now that I have that common denominator, I can combine them as 1. 1 plus y over y. Now, I've simplified my numerator, I've simplified my denominator. Now what I really have is division. And when we divide with fractions, we multiply it by the reciprocal. So I keep my first fraction exactly as it's written. Y plus x squared over xy. I take, and instead of dividing, I switch to multiplication. And I take the reciprocal of my denominator, which means my top goes to the bottom and my bottom goes to the top. A couple things we need to note here, guys. Restrictions on our domain. Here, we know that x cannot be 0. We know that y cannot be 0 from here and here. Okay, now we have one more right here. We have y cannot equal -1 if we take y plus 1 equal to 0. So these are the restrictions on my domain. I can simplify here. Again, with fractions, we multiply straight across. And anything divided by itself is 1. My final answer here is going to be y plus x squared over x times 1 plus y. And again here, if you wanted to, you could have written it as x plus xy in your denominator. Either one of those would have worked. I'm going to stop this one here because I'm not going to have time to finish the next example. So the next video will be our last one.